In this video, we'll start to talk about dividing polynomials with long division. So far in this chapter, we've talked primarily about polynomial functions graphically. In this section, we'll begin to look at them algebraically. In particular, kind of as a preview of where we're going, using long division or the other tool that we'll learn in the next video to divide polynomials will help us graph more complex polynomials. So we'll start with a quick example to motivate where we're going with this, and then we'll do a formal definition, and then look at a slightly longer example. So thinking back to, I don't know, maybe elementary school when you learn long division, we know that we typically set this kind of division up like 7 goes into 38 like this, right? 7 goes into 38 5 times in a bit, right? We know if we multiply 5 times 7, we get 35, and if we subtract 35 from 38, we get left with 3. So we can rewrite 38 divided by 7 as 5 plus 3/7. And this is kind of exactly what we're going to do with polynomials. The question that we're going to ask is, can we divide, using the division algorithm, one polynomial by another polynomial? So the division algorithm says if p of x and d of x are polynomials with d of x not equal to 0, then there exists unique polynomials q of x and r of x where r of x is either 0 or of degree less than the degree of d of x. So p of x divided by d of x equals q of x plus r of x divided by d of x. Or equivalently, p of x equals d of x times q of x plus r of x. P of x here and here is the dividend. D of x here and here is the divisor. Q of x here and here is the quotient. And r of x here and here is the remainder. And all this is saying is if we divide a polynomial by another polynomial, we'll get something out that's an even multiple plus a remainder over the initial divisor. So as an example, let's look at what happens when we divide x minus 4 into 6x squared minus 26x plus 12. So the dividend here is 6x squared minus 26x plus 12, and the divisor is x minus 4. So we arrange it like this, just like we would have in long division with two whole numbers. Now we divide the leading term in the dividend, 6x squared minus 26x plus 12, by the leading term in the divisor. In other words, what do we need to multiply this x by to get 6x squared? And our answer is what? Our answer is 6x. So we'll plop up 6x up top. The next thing we need to do is we take 6x and multiply x minus 4 by 6x. And we will arrange it like this. So we have 6x times x is 6x squared, and then 6x times negative 4 is minus 24x. So now we will subtract like this. So we'll have 6x squared minus 6x squared is 0. Negative 26x minus negative 24x. That gives us a negative 2x. The next thing we do is we bring down the next term in our dividend. So we'll bring down the 12 like that. So now we ask the same question. What can we multiply x minus 4 by to get something close to negative 2x plus 12? And we can say, okay, minus 2. So negative 2 times x minus 4 would be negative 2x plus 8. And now we subtract again. So we have negative 2x minus negative 2x, so that becomes 0. And 12 minus 8 leaves us with 4. So now once again I want to say we've got we've got the dividend, which is 6x squared minus 26x plus 12. We have the divisor, which is x minus 4. The quotient is 6x minus 2, and then the remainder is down here, it's just 4. So we can arrange all of this information in two kind of convenient ways. We can say 6x squared minus 26x plus 12 over x minus 4 equals the quotient, 6x minus 2, plus the remainder, 4 over the divisor. And this one is an interesting way to express it because if we put everything with a common denominator, if we multiplied 6x minus 2 by x minus 4 over x minus 4, and we did the addition, combined those fractions, we would get our original dividend and divisor. Equivalently, 6x squared minus 26x plus 12 equals, parentheses, 6x minus 2 times x minus 4 plus 4. And you can kind of see if we divide the second row entirely by x minus 4, what we're left with is our original row. So two different ways of expressing the same thing.